Good morning, M1. Today we start a new chapter, chapter 12, discrete probability distribution. First of all, let's talk about the last chapter, chapter 11. So up to now, I've just got a few of your homework, and for the quiz, I've just got 4 copies only. So I'm still expecting 6 more copies of your quiz. I believe that you have a big trouble in the last chapter. That's why you hand in these works so late. And please let me know whether the workload is too much or too less. The things are too difficult or too easy. So please give me some feedback so that I could adjust. Okay? Now, chapter 12, discrete probability distribution. So what are we going to learn in this chapter? Of course, we are going to learn the probability distribution, discrete. There are 4 types. The first one is Bernoulli distribution. The second one, binomial distribution. The third one, geometric distribution. And then the last one is Poisson distribution. So these 4 are very classic probability distribution model in statistics. We're going to learn them, the method, the formula, so that we can have a better idea of what is a probability distribution. First of all, today we're going to look at Bernoulli distribution. So after you learned this distribution, you may find that this is very easy. But the reason why we have to learn this distribution is that we have to learn the structure of a probability distribution, so that you can have a better idea when you are going to learn the rest of them. Okay? Now, I'm going to give you some examples. So, you have to tell me one of them is different from the rest of them. So, please pay attention. First of all, toss a coin. And then, the second event is answer a true or false question. The third event is pick a color from red and blue. Pick one color in between these 2 colors. And then the gender of a baby. And then toss a dice. So one of them is different from the other. Can you tell me which one is different? Baby? You may now look at the result. When you toss a coin, the result could be either head or tail. So we use this bracket to enclose all the possibilities. We call this the sample space. The sample space included all different results, all different possibilities. So when you answer a true or false question, the result could be either true or false, or correct or incorrect. And then pick a color. Of course, you could pick red, or you could also pick blue, but you can only choose one of them. The gender of a baby can be either a boy or girl, male or female. But when you toss a dice, the result could be 1, 2, 3, 4, 5, or 6. So obviously, this one is different from the other. And we call this event. They belong to the same category. We call them, the name is Bernoulli distribution. Bernoulli distribution are those events with only 2 results, and these are Bernoulli distribution. So let's talk about one more thing. For all these events, there should be one thing that you concern most. For example, when you toss a coin, you should be looking for something, either head or tail. So that you have to define what does it mean by success in this event. So if you are looking for a head, then head means success. And usually by Bernoulli distribution, the success we use 1 to denote. So that the sample space should be written as 1 and 0. 1 means head, 0 means tail. So when you answer a true or false question, so it depends on which one are you looking for, true or false. So if you want to have a false, then false means success. Then the sample space is 0 and 1. 0 means true, 1 means false, because 1 is success. To pick a color, if I want red, then red means success. So this is the sample space. And for the gender of baby, if you want to have a baby girl, then females means success. And the sample space is 0 and 1. All right? Now, let's look at a proper way to describe the probability. So for the first one, when you toss a coin, you're looking for a head. Usually, we put it this way. The event is toss a coin, and you let X be the number of head obtained, because you are looking for head. So X is the number of head. And we need the probability of success, so that we also need to know the probability of getting a head. This is the probability of success. It is 1/3 given to us, which is 1/3. And X is the number of head. Then we know that it must be a Bernoulli distribution, because the result is either head or tail. So that you could say X follows a Bernoulli distribution with the probability of success 1/3. X follows a Bernoulli distribution with the probability of success 1/3. X means the number of head. Okay? So this is a proper way to describe the probability event. Now let's look at one more. What about the gender of a baby? First of all, this event is that someone is going to give birth to a baby. So, and you let X be the number of female baby obtained. You want to have a female baby, so let X be the number of female baby obtained. And we need to know the probability of success, means that we need to know the probability of getting a female baby. So the probability of getting a female baby is 1/4. Then we can write down what kind of distribution X, this random variable, follows. We know that X follows a Bernoulli distribution because the result must be either boy or girl, male or female. And the probability of for success getting a female baby is 1/4. Okay? So next time when you see this, you should be able to tell what does it mean. X follows a Bernoulli distribution with the probability of success 1/4. Okay? Any questions so far? But too bad I can't hear you. And then after that, after you defined what kind of distribution the random variable follows, you have to tell the probability distribution. So there are 3 ways to tell the probability distribution. First of all, formula, and then a table, and then the last one is a graph. You can use either one of them to describe, to tell people how to do the probability distributed. And now let's look at the formula. Go back to this example. When you toss a coin, you're looking for a head, and then let X be the number of head. So X follow Bernoulli distribution with the probability of success 1/3. If you want to use a formula to describe the probability distribution, you could put it this way. The formula, you can memorize how to form this formula. Oh, let me write it down. So can you guess where am I now? I'm now at school. I'm now here, the Student Activity Center. This is a very nice place. So, how to form the formula? Very easy. If x, we know that x follows a Bernoulli distribution with the probability of success p, then the formula of the probability is, first of all, the probability of success to the power of x times the probability of failure. If the success is p, the probability of failure should be 1 minus p. And then what about the power? The power is 1 minus x, because we know that in this case, x could be either 0 or 1. So this is the formula of Bernoulli distribution. And now in this case, tossing a coin, to get the probability, to get the head, the probability is 1 over 3. So that the formula will become, first of all, probability of success, 1 over 3, to the power of x, and then times probability of failure. If success is 1 over 3, then failure is 1 minus 1 over 3, to the power of not x but 1 minus x. And we know that the x could be either 0 or 1. So this is the formula. By using the formula, you can find all the probability, because x could be either 0 or 1. So when x is 0, anything to the power of 0 becomes 1. 1 minus 0 is 1, or 1 minus 3 is 2 over 3. That means probability for getting a tail is 2 over 3. And what about probability of x is 1, means getting a head? The probability is, x is 1, so 1 over 3 to the power of 1, which is 1 over 3, times 1 minus 1 over 3 to the power of 1 minus 1, which is 0. So anything to the power of 0 becomes 1. Therefore, the result is 1 over 3 to the power of 1, which is 1 over 3. So by using the formula, you can find all the probability. Okay? So therefore, we have the formula. Probability x equal to x is for probability of success to the power of x times probability of failure to the power of 1 minus x. And I forgot to put it down. You have to also write x equals to 0 or 1, either 0 or 1. Okay? The second way to describe the probability is using a table. So, as we know all this probability already, so that you could easily draw a table. Oh, forgive me not using a ruler. So these are the value of x. We know that it could be 0 or 1. And this is the probability. X equal to x. So here, when x equal to 0, the probability is 2 over 3. When x equal to 1, the probability is 1 over 3. So this is a table also a very good way to tell people how do the probability distributed. How does the probability distributed? Okay. So the second way is using a table. And then what about the last one? Also very easy. As you know all the probability already, you could easily draw a graph. So the horizontal axis is x, the vertical axis is probability, x equal to x. So there are only two values of x that you have to consider. When x is 0, the probability is 2 over 3, so that you draw a bar. When x is 1, the probability is 1 over 3. Here the height is 1 over 3. Okay, so this is the graph. So that the last way is using a graph. Right? So this is how we describe the probability distribution. And now, what about the second case? What about someone is going to give birth to a baby? The probability of getting a female baby is 1/4. So let X be the number of female baby obtained. X follows what below this distribution. Success means getting a female baby is 1/4. So that we could use a formula. The formula is probability of success to the power of X times probability of failure to the power of 1 minus X. And you also need to write for X equal to 0 or 1. Okay? And then the table. Draw the table, find the two probabilities, or you may also use a graph using this graph. Okay? And what's next? Next we should look at a general case. Let's look at a general case. So let X follows a Bernoulli distribution with probability of success P. Then we could say X follows a Bernoulli distribution with the probability of success P. So that, let's use the table. The probability of X equal to 1 means success. What is this probability? Yes, it must be P, right? Probability of success is P. Then what about failure? What is that? What is the probability of X equal to 0, failure? Yes, if the probability of success is P, then the probability of failure must be 1 minus P. Okay? Let me put it down here. Sorry, I need a paper. Okay, here. Put it down properly. I need a ruler. Oops. Oh, too bad. I don't have a ruler. Go ahead. So we have X follows a Bernoulli distribution with the probability of success P, so that we could easily tell how does the probability distributed X equals to X, 0 and 1. Probability of success is P, so this is P. Probability of failure should be 1 minus P. Okay? Now, can you tell me, do you remember how to find expected value of X? Expected value of X. Still remember? Just use each of the value of X times the corresponding probability. So 0 times 1 minus P plus 1 times P. This is how we get the expected value. 0 times anything is 0. 1 times P is P. So that the expected value of X is P. Remember how to find the variance? Before we find the variance, we should find expected value of X squared first. Okay? Now we need to find the expected value of X squared. Therefore, for each of the value of X, we have to put a square. That means 0 squared times 1 minus P plus 1 squared times P. What is that? 0 squared is still 0. 0 times anything is 0. Plus 1 squared is 1. 1 times P is P. Oh, it is also P. Now, we've got enough information to find variance of X. Do you still remember the formula? How to find variance of X? Expected value of X squared minus square of expected value of X. Remember this formula? Okay. Expected value of X squared is P. And expected value of X is P, so P squared is P squared. Therefore, we could factorize, take the p out, and then we have this, p times 1 minus p. Okay, so for a general case, for all Bernoulli distribution, with the probability of success p, the mean should always be p, probability of success, and the variance is probability of success p times probability of failure 1 minus p. Okay? Okay, so now we've got a very useful result. We have to memorize. For all Bernoulli distribution, we can easily tell the mean and variance. Okay? So this is the reason I don't want to use PowerPoint, because everything is shown up instantly, too fast for you, so that you don't have the time to digest. So expected value of x is p, expected value of x squared is also p, variance according to the formula is p times 1 minus p. So this is the result. For all x follows a Bernoulli distribution, then we have these two results. So we are going to remember how many distributions that we are going to learn in this chapter? There are 4 distributions. This is the first one. For each of the distribution, you have to memorize how to define the distribution, how to find mean, how to find variance, and also one more important thing is that you have to know how to find the formula. Okay, formula is also you have to memorize. So I guess that's it. Oh, one more thing. Okay, so let's go back to this example. Toss a coin. Probability of success is 1/3, and then you know how to find the formula. Write down the formula and table, and then to find mean and variance. Okay, so please tell me, what is the expected value of x? Expected value. Yes, expected value is just p, probability of success, which is 1/3. And then what about the variance of x? Variance of x is p times 1 minus p. So in this case, p is 1/3, so 1/3 times 1 minus 1/3. 1/3 times 1 minus 1/3, which is 9. So that we could easily tell the mean, the expected value and variance. One more, what about this case? Give birth to a baby. To get a baby girl, the probability is 1/4, so these are the probability distribution. So what about the mean? Can you tell me what is the expected value of x? Expected value of x is 1/4, right? And variance, what about variance? How to find variance? P times 1 minus p. So 1/4 times 1 minus 1/4. So that's 3/12. Oh, I forgot to simplify. 3/12 means 1/4. So it is also 1/4. Mean and variance are the same in this case. Interesting. Okay? And then, oh, yes. Have you received the worksheets in chapter 12? In chapter 12, you have 4 worksheets. So today's homework, you have to work on homework A. Chapter 12, homework A. Okay, I would like to do 1 question for you, so that you have a better idea how to do it. A random variable x follows a Bernoulli distribution, and this is the formula. This is the formula. Now, from this formula, can you tell me what is the probability of success? So we know that the formula is p to the power of x times 1 minus p to the power of 1 minus x, right? So that means that probability of success is 3/10. 3/10 is probability of success. Okay, so that we know that x follows a Bernoulli distribution with the probability of success 3/10. Okay, and then we could easily tell how does the probability distributed. I would like to use the table. X and probability of x equal to x, we have 0 and 1. Probability of success is 3/10. means that probability of failure 1 minus 3 over 10, which is 7 over 10. Okay, so this is the table. And look at the question. Oh, we have to represent the probability distribution graphically. We have to use a graph. So draw the graph. You are supposed to use ruler. Don't copy me. I don't have ruler now. Now, x and probability of x equal to x, and the x could be 0 or 1. For 0, the probability is 7 over 10. So this is 7 over 10. And for 1 is 3 over 10. Okay, done. And then part B. You have to find mean and variance of x. Could you do that? X follows Bernoulli distribution. 3 over 10 is the probability of success. So the mean means expected value of x should be, yes, just p, which is 3 over 10. And the variance, according to the formula, is p times 1 minus p. Okay? Okay, so this is 7 over 10, 3 times 7 become 21. 21 over 10 times 10 become 100. So it is 21 over 100. Okay? So don't be lazy. Finish this worksheet. And then we will see each other again on Friday. Goodbye.